students, in this lecture we will study UV spectroscopy. UV spectroscopy involves absorption of light in UV and visible region. By the compounds under investigation. As in our previous section, we have studied that UV spectroscopy causes electronic transition within the molecule. Electronic transition involves not only single line. If it involves only E1 level and E2 level, then we must have got the single line. But these electronic levels are further subdivided into vibrational level, and vibrational level is further subdivided into rotational levels. Similarly, as I have drawn the rotational and vibrational levels for the ground state, similarly we have level vibrational and rotational levels for the excited energy level also. It means if we excite one electronic level go from one electronic level to another electronic level, vibrational and rotational levels are itself gets excited, and we never get a single line in the spectra. We get actually series of lines that appear as a band. So it is called band spectra. As it involves electronic transition, it is also called electronic spectroscopy. In this spectroscopy, the important question is the wavelength range used to excite one electronic level to the another electronic level is UV region. Two regions are used, UV and visible region. UV region range from 100 to 400 nanometer, while our visible region range from 400 to 800 nanometer. The UV region is further subdivided into two regions, that is far UV region and near UV region. Far UV region range from 100 to 200 nanometer, while near UV region range from 200 to 400 nanometer. However, at 150 nanometer or below, nitrogen starts absorbing. And below 200, oxygen starts absorbing. So, before studying the sample in UV region, inert environment is needed. So, first of all, sample should be deoxygenated before taking the spectra. As I have said, that before 200 nanometer, oxygen gas and the nitrogen gas starts absorbing. It means if we want to study the sample, below 200 nanometer, then we have to use the vacuum region. It means we have to create the evacuated system. The technique is useful for predicting the conjugation. What is conjugation? It is alternate double and single bond present in the compound. It is also used to elucidate the unsaturation in carbonyl compounds. To study these compounds, there are two laws used, or laws of absorption, called laws of absorption. These two laws of absorption are Lambert law and Beer's law. What Lambert law says? Lambert law says that when a beam of radiation passes through a homogeneous medium, the rate of decrease of intensity of the radiation with thickness of medium is directly proportional to the intensity of the incident radiation. Mathematically, that is minus di by dx is proportional to incident radiation. Diagrammatically, first of all, we should be aware what is I naught. I naught is the incident radiation, and this is our sample. We have selected a smallest portion of the sample, that is of thickness dx. Suppose I naught gets entered to this section and decrease in intensity is minus di, and after absorption of the small intensity by the thickness dx, the transmitted light is IT. So rate of decrease of intensity with thickness of medium according to Lambert's law is proportional to incident radiation intensity. So not going into the derivation, I directly write here the expression, that is I is equals to, this is differential format. Proportionality constant is converted into K I naught, and it is written as I equals to I naught. Integral format is minus Kx. Now Beer's law. What is Beer's law? Beer's law is actually based on Lambert's law. Lambert's law says that rate of decrease of intensity with thickness of medium is proportional to intensity of incident radiation, while Beer's law says that rate of decrease of intensity with thickness of medium is not only proportional to intensity of the incident radiation but also depends upon the concentration of the solution. Means concentration means how many molecules absorb the radiations. So in this case we use the symbol of constant epsilon. The combined form of Lambert and Beer law is called Beer-Lambert law. Mathematically, it is given as A. A is absorbance, that is equal to log of I naught by IT is equals to epsilon CL. What is I naught? We have already explained. It is intensity of incident light. And I, T is intensity of transmitted light. C is concentration of solution and L is the length of cell. These were the laws. Now we will study the types of transitions which are possible in the compound while studying the UV spectroscopy. For example, if we take formaldehyde molecule, suppose in formaldehyde molecule we have three types of molecules. Electrons are present: sigma, pi, and non-bonding electrons. Initially, when electron is present in the ground state can be sigma, pi, and non-bonding. Non-bonding means they are not involved in the bonding, while sigma and pi electrons are involved in the bonding. When they get excited to the higher energy level, they can go to their corresponding anti-bonding molecule. Depending upon the types of electron present in the ground state, there are four types of transitions possible. First transition, which is of highest energy transition, that is sigma to sigma star transition. Second transition which is possible, which is of lesser energy, is N to sigma star. Then comes N to pi star and pi to pi star. So we have four types of transition: sigma to sigma star, N to sigma star, third N to pi star, fourth pi to pi star. These four types of transition follow the energy order. Sigma to sigma star is the highest energy transition, and then comes N to sigma star, then comes pi to pi star, then comes N to pi star transition. When we move from in this order, the energy is decreasing. The detail of these four transitions we will discuss in next section.